Hello, good day. Again, this is Engineer Ernesto C. Prudenciado Jr. and welcome to my channel. Okay, so let's continue with our discussion in integral calculus. We are now in definite integrals. This is a new topic, no? So, many applications of calculus involve definite integral, one of which is getting the area of an irregular shape with ease. Thus, it is necessary that we discuss definite integral. Knowledge in indefinite integral, our previous topic, is needed in evaluating the definite integral. Okay, so as we all know, no, one of the application of integral calculus is to know or getting the area of an irregular shape, no, as stated here, irregular shape, no. So before going into that, let's discuss first the fundamental proof of calculus, no. That if you integrate a certain function, no, which we always do here, that will resolve to the area under that function. Okay. So I already drawn the figure, no. So if I have a curve, the green one, no, and let's call this as function of x. Okay. So I also have an area which is a function of x now under the curve, this one. Okay. So if I will add this one, vertical line, and I will denote this as delta x, okay, so that I have a new function, differential area. Okay, to get the total area, so this becomes a function of x plus delta x, no, and which is equal to ax plus, what is the area of this? That is what? Y, because you have here the height is y delta x, no? So I will write this as area x plus delta x equals ax plus, what is y? Y is function of x, right? So function of x delta x. Okay, so rearranging this, I can have f of x delta x equals a x plus delta x minus ax. Okay, so we have now this equation. Okay, so recall your limit definition of derivative, no, in your bridging program. So I already discussed that. So if you have this function, a function of x, no, what is the derivative of this? So the derivative is a prime. Okay, that would be what? A x plus delta x minus a function of x over delta x. Okay, so if I may arrange this, this becomes what? A prime x times delta x, no, equals a x plus delta x minus a function of x. Okay, so again, no, this is from the limit definition of derivative, no. We discussed this already during bridging program. Okay, so what have you noticed? This equation is also equals to this equation. Okay, therefore function of x delta x is equals to the first derivative of area. Okay, so therefore if I will integrate this, this becomes what? Integral of f of x. Okay, but delta x, I can change that as dx. So equals to a function of x. Okay, so what have you noticed in our expression? So if we integrate a certain function, no, the result would be the area under that function. So this proves now the fundamental definition of calculus. Okay, again, if we integrate a certain function, no, the result would be the area under that function, with a certain limit, no? Assuming that the curve is continuous. Okay? Okay, so let's go to the example, no? So, evaluate integral of x plus 1 squared dx, no? Limit from 0 to 1. Okay? So, this is now the definite integrals because we have limits, no? The lower bound and the upper bound. Okay? So, I will write first integral of 0 to 1 x plus 1 squared dx. Okay? So, from inspection, I can say that I can use the power formula because if I let u equals x plus 1 and du would be dx. Okay? So, substituting u and du to the original equation, this will be 0 to 1. And this is u squared, dx is du. Okay? So, I can now use the power formula. So, this will be what? U 2 plus 1 over 2 plus 1. Okay? Limit, wala nang, there's no plus c here because this is again definite integrals. Okay? 0 to 1. Okay? So, this will be u 3 over 3, 0 to 1. And I can substitute back the original value of u, which is x plus 1, no? Cube over 3. Limit from 0 to 1. Okay, first, you have to plug in the upper limit. So, this is 1 plus 1 cube over 3 minus the lower limit, which is x now is 0 plus 1 cube over 3. Okay, so we can simplify this. 1 plus 1 equals 2. Cube is 8. 8 over 3 minus 0 plus 1 is 1 to the cube is 1. So, this is 1/3. So, the answer is equals to 7 over 3. So, this is now your final answer. Okay? So, let's jump to problem number 2. So, evaluate integral of a2 minus t squared dt with limits negative a and a. Okay? So, by inspection, I can rearrange this as negative a squared. I will distribute the dt minus t squared dt. Okay? So, I can individually integrate this one. This becomes what? A squared t minus t cubed over 3. Okay, with limits negative a to a. Okay, so there's no plus c again, no, because this is now definite integrals. So I can plug in now the limits. So first is the upper value. A squared, t now becomes a minus t minus a cubed over 3. Okay, minus the lower limit. So, a squared times negative a minus negative a cubed over 3. Okay? So, simplifying, this becomes a cubed minus 1/3 a cubed. Okay? This becomes negative times positive because becomes positive a cubed. Okay? And this becomes negative times negative positive. So, this becomes negative 1/3 a cubed. Okay? So, further, this becomes 4 over 3 a cubed. Okay? So, this is now your final answer. Okay? Very easy. Okay, so let's jump to problem number 3. Evaluate integral of z times a squared minus z squared close parenthesis to the power cube dz. Okay, so let me write first the equation. 0a z a2 minus z2 cube dz. Okay, by inspection, we can let u equals a2 minus z squared, so that du would be a squared is constant, therefore it will be 0. So this becomes 2z dz. Okay? So therefore dz equals to du over negative 2z. Okay? I can now substitute the value of u and du to our original equation. So z, what is this term? This becomes u cube, no? dz is du over negative 2z. Okay? So this may cancels out. So factoring out negative 2, this is negative 1 half, 0 to a, u cube du. So I can now use the power formula. So therefore, this becomes u3 plus 1 over 3 plus 1. Okay, so limit from 0 to a. Okay, so negative 1 half, this becomes u4 over 4, limit from 0 to a. Further, this becomes u4 over 8, limit 0 to a. So I can now substitute the value of u. This becomes negative a squared minus z squared to the power 4 over 8 with limit from 0 to a. Okay? So I will now substitute or plug in our values, our limits. So this becomes a, this is constant, z is now a squared over 8, no, to the power 4. Okay? Minus a squared minus 0 squared to the power 4 over 8. Okay? So this becomes negative a squared minus a squared is 0. So these terms will be 0. So this becomes negative plus times negative. This is positive already. So therefore a squared minus 0 squared. So this becomes what? A to the 8 over 8. Okay? Positive. Because negative times negative becomes positive. Okay, so this is now your final answer. Okay? Very easy. Okay, thank you for listening. Hope you learned something from me today. So, bye-bye. Take care. God bless.